All right, this is Mr. Gillum, and today you're in luck. We're doing more fraction work. What we're going to do today is we're going to add fractions and subtract fractions and add negative fractions with positive fractions and all the other different things we can do with the positive and negative parts of it. However, there's going to be a catch because now, unlike yesterday, they're all going to have different denominators. And so we're going to learn how to put fractions together that have different denominators. All right, so that's what I want you to be able to do. By the end of all this, I want you to be able to add and subtract them, positives and negatives, even if they have a different denominator. That's the goal. So here's what we're going to do. We're going to go back all the way to the basic roots, the ittiest, bittiest, teensiest, weensiest little part of the entire thing, multiples. That's what it all comes down to, is multiplication. Even though we're adding, subtracting, it all comes down to multiples. Basically, what a multiple is it's a number that you can divide into, okay? Or whatever number it is, you can multiply to get another number. So I guess all those words are very confusing. I think I just confused myself a little bit there, but basically here's how it works. A multiple is like a 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, and so on, and forever and ever and ever, and it goes on forever. There's infinitely many multiples, but what we need is something called the least common multiple. All right, now I know you have these on your paper, but multiples of 3, 3, 6, 9, 12, 5, 5, 10, 15, 20. One of my favorites are the 9s. The 9s are tricky. 9, 18, 27, 36, and so on and so on and so on. Those are all multiples. Okay, so sometimes I see people get mixed up with factors and multiples. Multiples keep getting bigger and bigger and bigger forever and ever and ever. So here we go. What I want you to know is this. Different numbers have common multiples. They share multiples. Like, look at all these multiples I have here. I have a 6 in the 2 column, and I have a 6 in the 3. 12's over there. Look, they share a lot of these. 24's in there. 30's in there eventually. 28, 30. Do you see how they share different multiples in different columns? Even 5. 5, let's just do a different color here. 5 would share a 10 with a 2. Or a 20 with a 2, or a 30. Oh, but with that, it also shares it with 3 as well. Or even right here, look at this, they share a 15. And so the reason I have all these multiples written out for you is because there's something that has to happen when we get to this fraction thing where we have to add them together. And the thing is that they have to have the same denominator. And you might have known that, or you might have forgot that, but when we're adding and subtracting fractions, they have to have the same exact denominator. And to do that, what we have to do is we have to find the least common multiple. And then we end up calling it something else, LCD, the least common denominator. But really what it is, it's the least common multiple. So for today at least, I want you to write out as many multiples as necessary until you find the first one that the two numbers share. Okay, so for example, let's just see if I can clear this out here. Okay, so they obviously share. If I was trying to find the least common multiple between 2 and 3, it would be the first one that they both share in common. So I would look right here at the 2, and I don't see it in this one. And this one isn't shared with 4, but I do see that 6. If it's the first one that I find, it's the smallest one. So the least common multiple between 2 and 3 would be 6. Or if I wanted to compare 3 and 5, okay, I would say, okay, well, 3's not in there, 6 isn't in there, 9's not in there, 12's not on there. Oh, but they do share 15. So the least common multiple between 3 and 15, 3 and 5, would be 15. Okay, so these lists are going to come in really handy, seeing which multiples they share. And in fact, we want always the smallest multiple that they share, the least common multiple. Now, here's the thing, though. We have to actually understand what we're doing. I know it's rough, but we have to. So here's what's going to happen. Let's just talk about the number 1. The number 1 has some special properties. There's different ways to write it. We could write it as all kinds of stuff, a proportion, 1 to 1. We could write it as division, 1 divided by 1, or division even like this, 1 divided by 1. Or we could even say 1 squared, that would still be 1. Or we could even write it as 5 divided by 5, or 6 divided by 6, or 300 divided by 300. These are all just different ways to write the number 1. They're just different ways. Or we could even say 5 divided by 5 like this, like a fraction. And these are going to be very important for today because we need to understand that these fractions that we're going to be multiplying, they're just equal to 1. And so there's these fancy properties, and we have fancy names for these things. I know that whenever I multiply 1 by something, like 3 times 1, it's still equal to 3. It doesn't change its value. It keeps its identity, and so we call it the identity property. 5 times 1 is still 5. Elephant times 1 is still elephant. Okay, it doesn't matter. It's the identity property. If you multiply something by 1, you just have one of it. It keeps its identity. All right, and so the identity property says it doesn't matter. As long as you multiply by 1, it stays the same. The multiplicative inverse property, ooh, that sounds fancy. Here's what that one says. If I want to know how many times does 3 go into 3, I know it is 1. Or if you like it better, 3 divided by 3, that's fine too, but we need to really be thinking like this for what's going to come in a second. Okay, so whenever you divide something by itself, you equal 1. So 1's everywhere. 1's everywhere. 15 divided by 15. Even that's 1. Everything's 1. And that's called the multiplicative inverse property, believe it or not. And I know it says multiply and we're talking divide, but later on you're going to learn, or maybe you have learned, that 3 divided by 3, and oh, I know we have done this, 3 times 1/3 are the same thing, and they both equal 1. So 1's just show up everywhere. And so we have the identity property and the inverse property, and we're going to multiply them and smash them together, make this huge mutation of a property thing that we're going to use to help us get our common denominator here in a second. So let's take a look. What we have here is a formula for success for adding and subtracting fractions with different denominators. Now, yesterday we've learned and we've practiced fractions like this: 1/2 plus 3/2 equals 4/2, and we even reduced that into 2 because 4 divided by 2 is in fact 2. And we learned this and we practiced this, and it seemed like it was just too easy because always these numbers matched. But however, today everything changes. We're going to add a little step of difficulty here. So we can do it. Step 1, find the least common multiple between each fraction's denominators. Oh my gosh, it sounds so confusing, but don't worry because I'm going to show you how to do it. Find the LCM, the least common multiple between each fraction's denominators. Okay, so I see these denominators here of 3 and 2. And so we need to find the least common multiple. So I'm just going to label it 3, 6, 9, 2, 4, 6. And oh, I know right away, I don't have to go any farther. That's fine. I got these lists of multiples for each one. I know that 6 is the first one that they both share in common. Now the second step can be a little tricky. All right, so step 1, check. We've done that. We decided that is 6. Our least common multiple is 6. Now, the next step, decide which multiple it was for each fraction. That sounds really confusing, but it's not that bad. Okay, once you see what I mean. For 3, this was the first multiple, and the second multiple, and the third multiple. For 2, this would be the first, second, and third multiple. Now, for 3, the number 3, I'm looking at the second multiple. For 2, I'm looking at the third multiple. All right, so that's like its place value in the number of multiples string that goes on forever. Okay, so I'm deciding that for 3, it was the second multiple, and for 2, it was the third multiple. Okay, so we've done step 2. What I'm going to do with that information, I'm going to multiply the top and bottom of the fraction by its multiple number. So what I'm going to do is this. I'm going to look at this first fraction. I'm going to write it down here so I have plenty of room. 2/3. And what I'm going to do is I'm going to multiply the top and bottom of the fraction by its multiple number. And because I'm talking about 3, I'm looking at the multiple number of 2. So I'm going to multiply it by 2/2. All right. And also, I'm going to do it with this one as well. The second fraction, 1/2, I'm going to multiply by 3/3. So I have these two new transformed fractions, but we must understand why we're doing this, or what it is that we're accomplishing. We have practiced multiplying fractions, and we know that 2 times 2 is 4, and 3 times 6 is 3 times 2 is 6, and we can do that with both of our equations, but the end result is the important part. What we're going to end up with here is 4/6 and 3/6. Now, what we did was we multiplied by 1. And the identity property says, well, hey, as long as you're multiplying by 1, it's okay. They mean the same thing. So I know even though I multiply by this, I know that 4/6 and 2/3 are the same, and I know that 3/6 and 1/2 are the same. So now, instead of trying to add these fractions with different denominators, I had this new equation here. 4/6 plus 3/6, and life is good again. Because I know that I can add them together, 7/6. And so the important part to remember here is the value is not changed because we're dividing something by itself and that's equal to 1. And when we multiply something by 1, it's the same thing. So we're going to add our new fractions together, which I kind of jumped the gun there, right there. And I'm going to reduce if I have to. 7/6 in this case. There's no reducing there. I don't want you to change it to an improper, or I don't want to change it to a mixed number. You can just leave it as an improper fraction. That's fine. So what we need to do is we need to practice. That's the key. We need to practice. And we're going to start with some simple addition and subtraction. And we're going to actually throw in those positive and negatives, extra signs later on, because we know the song. That's going to help us with the change, and the row your boat and all that deal. So don't worry, we're going to get to that in a second. But let's just talk about these fractions here. First things first, I noticed that this fraction doesn't have matching denominators. So I'm just going to make a list of 4 and 5 of their multiples. 4, 8, 12, 16, 5, 10, 15, 20. All right. And let's just find the earliest one. I don't see one that they have in common. I better keep going. Oh, I noticed that they both share a 20 in common. And so what I need to do is I need to label and make sure I get the right multiple number. That's the 5th one, and for the 5, it's the 4th one. So what I need to do is I need to approach this problem. I'm going to change the 3/4 and I'm going to change the 2/5 into different fractions with the same denominators. It'll be worth the same amount, but it'll have the same denominators, which will be good for us. So I'm going to take 3/4, and I'm looking at the 4 column because I've got the denominator of 4. And I'm going to multiply it by, since I want this 20 to be my least common multiple, I'm going to multiply it by 5/5. I'm going to take this 2/5 here. I'm going to multiply it by, because I have this 5 here, I'm looking at my 5 column, the 4. Now, you might be thinking, okay, there's a lot to memorize, all this stuff. Now remember, to add our fractions together, we need to have the least common, or we need to have a common denominator. We need to have the same number on the bottom of the fraction. So if I change this 3/4 by multiplying it by, what we're really doing is multiplying it by 1, but really we're just going to make it look different because 5 divided by 5 is 1. We're just going to make this fraction look different, and I'm going to multiply straight across 15/20. Now if I reduced it, I'd be right back to 3/4. This is just multiplying by 1. It's not changing the value. So I have 15/20 now. And I also have 2/5 times 4/4 over here, 8/20. I can't believe it. Looks like we're going to have some common denominators now. And if I wanted to reduce 8/20, believe it or not, it would actually reduce to 2/5. So what I've accomplished here is now instead of 3/4, when I'm looking back at my original problem here, instead of writing 3/4, what I'm going to write is 15/20. And instead of writing, I'm still going to have my plus sign. Instead of writing 2/5, what I'm going to write is 8/20. And now, believe it or not, I can add these together because we've been practicing this. We know how to add fractions that have the same denominator. 15 plus 8 is 23 over 20. There's nothing to reduce, nothing I need to change. That's as good as it gets, and that's fine. But the good news is I have this nice fraction that I couldn't put together before. Okay, because remember, these are the divided parts of the unit. 3/4 is represented by this much of a unit, and 2/5 is represented by, ooh, this is going to be tricky. 1, 2, 3, 4, 5, close enough. 2/5, that much of it. So it makes it hard to put them together. But we can, if we change them both, to have the same divisions, the same number of divisions. All right, so what we're going to do, because I've gotten on and on and on and on, what we're going to do is we're going to continue on with some examples in class. All right, so today, or I should say tomorrow, when you get to class, we're going to hold off on logging in, and we're going to continue on with this so that you all can hear it right from me in class, in person, and you can ask the questions that I know you might have. All right, so tomorrow, come on in. I want you to, normal routine, grab your papers. I want you to have a seat. I want you to turn your homework in, and I want you to listen to a glorious math lesson on fractions.